this is the video for our Kinetics Lab. So a couple of new pieces of equipment for this lab. The first is we are going to be using what's called colorimeters. Colorimeters use light and the relationship called Beer's law to form a relationship between concentration and absorbance value. So we will talk about that in a pre-lecture before the lab, what that actually means. One thing you do need to know about the colorimeter is, it's kind of hard to see, but this is where you're going to put the little cuvette, and you cannot forget to take the cuvette out at the end of the hour because they get bumped around and then the liquid spills in there and they're destroyed. So please do not forget to take the cuvette out at the end of the hour. The second new piece of equipment that we're going to be using is called a Cuvette. They are little square type test tube sort of things. There are two sides to them. One side is rigid and the other side is solid. The side you want to touch is the rigid side. Since light is going to be passing through here, any kind of fingerprints or any dirt on it will affect your results. So you only touch the cuvettes on the rigid side. Also, these are disposable, so we will throw them away after your experiment. Okay? So I'm going to I have gloves on and a lab coat because we are using crystal violet solution, which is a biological stain, so it will stain your clothes, and it's best to keep it off our hands, so we're going to be using gloves as well. All I did was I plugged my colorimeter into my LabQuest. The LabQuest automatically can tell what we are doing, so absorbance values are turning on or showing right away. The first thing that the lab has you do is prepare a blank. A blank is a cuvette that only has distilled water, and in our case it's distilled water because distilled water is our solvent. So we want the the colorimeter to ignore the water that's in our solvent or in our solution and only read the values of the solution, the crystal violet solution that we're using. So what we do is we take distilled water, fill it 3/4 of the way. I'm only touching the rigid sides. Our next step for using a cuvette is we take a microfiber cloth and we wipe down the non-rigid sides. Any kind of fingerprints or anything we want to get off, we want it to be a perfectly clear piece of plastic. If there are any bubbles, you want to dislodge those as well. When we take a look at the colorimeter, you notice there is a white arrow. That is where the light is shining through to read our concentration. So holding the ridge side only, we are going to line up the clear part of the cuvette with the white arrow. So the clear part lines up with the white arrow, and we go ahead and close. I'll move this so you can see. Go ahead and close the door. Okay, now I just noticed that the door came off on this one. Now we don't really want to touch the colorimeter at all, and I'm going to because we don't want to lose any of that water into the solution because it messes it up. Now I just noticed that this is starting to collect, so I'm going to hit File, New, Discard. Okay, so the next thing we're going to do is we're going to calibrate our colorimeter. To calibrate our colorimeter, we are going to set the wavelength to 565 nanometers. So I'm just moving the arrow over to 565 and hitting the cal button, and a red light will be blinking. I don't know if you can see that. And as soon as it stops blinking, it has been calibrated. Once it's been calibrated, you can open the lid, take the little cuvette out, and you're going to dump the water out for now. Okay? The next thing it has you do is it has you change the amount of time. So where on your LabQuest, where it says time, and I don't know how easy this is for you to see, but where it says duration, you want to click on that, and we are going to change the duration to 180 seconds. 180, done. Okay? And click OK. So I just changed my duration. I hit it and I changed it to 180 seconds. So now I'm ready to begin. what I'm going to do is I have two different color graduated cylinders to keep track. So I'm doing crystal violet in a yellow graduated cylinder, and then the sodium hydroxide in the red graduated cylinder. Chances are you won't need to do more than one trial, but just in case, you don't have to wash them out extra time. We'll be able to tell if you have to do a second trial if your R value is pretty high, or pretty low actually. Closest one is good. You might have to do a second trial. So I have 3 milliliters and I have 3 milliliters. Taking a clean little beaker, I am going to simultaneously mix these in here, and my reaction has started. It says to use a stirring rod to stir it. I think swirling is just fine. What I'm going to do next is called rinsing and preparing the cuvette. So same cuvette that I calibrated with. So I calibrated out any imperfections in the cuvette. I'm going to use that same cuvette. I'm going to again rinse it with distilled water, dump that distilled water out. Then I'm going to rinse it with the reaction solution. I want the very last thing to touch the inside of that cuvette to be the solution that I'm monitoring. So I'm going to use a eyedropper, and I'm just going to suck up some of my reaction solution, and I'm just going to kind of swirl it around so the only thing that touches it is the solution. Go ahead and dump that out. I'm ready to collect data. So the very last thing I want to do is, remember, holding it on the ridgy side, is I'm going to fill it 3/4 of the way. So using my eyedropper, I'm just going to fill it 3/4 of the way. So it looks like that. Doesn't have to be perfect. Wiping off one final time. I do have some bubbles, so I'm just going to tap it a little bit. Good. Wiping it off. Now, it goes in my colorimeter again. The non-ridgy side, that clear side, is lining up with the white arrow, and I'm going to close the top. Once I'm set, I'm going to hit play. And it's going to go ahead and collect the data. Now, the data that it's collecting is absorbance value on the x-axis and time on the y-axis. Beer's law tells us that the absorbance is proportional to the concentration. So you can kind of think of this as a zero-order graph. I have concentration versus time. I'm trying to figure out what order that this solution reacts in. Is it first order, zero order, or second order? So as I'm watching my graph, which is absorbance versus time, but it's kind of like concentration versus time, I can see whether it looks linear or not. As soon as the 3 minutes is up, I am going to take a look at my data table, and I'm going to graph it 3 different ways: the concentration versus time, which I kind of already did, natural log of concentration versus time, which is natural log of absorbance versus time, and then 1 over the concentration versus time, and see which one is linear, get my linear regression line, and move on from there. So since that actually takes place on the LabQuest, I'm going to stop this video, and I will show those steps using the smartboard so you can see what buttons I'm pushing for that. So this is just going to continue on for the 3 minutes. Remember, rinse and prepare your cuvette and calibrate it with a blank. A blank doesn't mean empty. A blank means distilled water, and we calibrate it. And then rinse means distilled water. Prepare means solution. Dump it, solution fill. Always hold it from the ridgy side and wipe it off. Okay, so this is the video of what to do after you have your initial graph finished. So the 3 minutes have went by. As time went on, the absorbance values went down. So this would be what the zero order graph would look like. Now you have a couple options. I suppose you could go into the table tab, and in the table tab you could get out your calculator and list all the time and all the absorbance values. I just feel like that would take a really long time, because we have 3 minutes worth of data. So instead what we could do is we can actually graph it the two other ways, so 3 ways total, in the lab quest. So what we're going to do is go ahead and hit that table tab. So I went from what looked like this because I hit stop, or it stopped afterwards. I'm just clicking on the table tab there, and I'm going to add in a new calculated column. So kind of like when we go to list 3. So what we do is we hit table. Now I'm just using a stirring rod to do this. It's a little bit skinnier than my finger. And I go new calculated column. It's right here. New calculated column. I'm just going to name it natural log. You could name it whatever you want. It has you write natural log ABS on the instructions, but it really doesn't matter. Okay. I am going to set my equation. So equation type here, and you have to scroll down quite a bit to find the right one. It's right here, ALNX. So the natural log. And it's really important that you change this column for X to the absorbance value. The transmittance value is not proportional to concentration, but the absorbance values are. So I'm going to change that to absorbance. So this is what it should look like. Give it some kind of name if you want. I don't even think you have to. The natural log of X for the equation type and absorbance there, and go ahead and hit OK. So I take a look at that graph and it looks straight. I'm going to go ahead, and so that would be my first order graph. I'm going to assume that that is straight, and so that would make it a first order. What I need though is the equation for that line, because I need to get my K value and all that other stuff. The processing the data questions ask you for that kind of stuff. Don't forget to write this down. I'm going to go to Analyze. I want a curve fit. If I had more than one graph going on here, I would pick the one. I'm going to curve fit the natural log graph that I just made. It's kind of like choosing list 1, list 3. The curve fit that I want, so I'm picking here, is I want linear because I want my y equals mx plus b, and it pops up. So my correlation, my R value is 0.999, did I say enough nines? 4. So that's excellent. I will not need to do another trial. If yours is in the 0.8 range, you definitely need to do another trial. So I have really nice data. I am going to write down the equation, y equals mx plus b. We know that y isn't actually y, it's the natural log of the absorbance values, and b is the natural log of the initial value. So write all this down, and then even including your correlation number, because we'll pick a winner, winner, chicken dinner, who has the best one, and then you can go on from there. So hit OK. So there we go.